Okay, today we are going to calculate the volume calculation in Agisoft Metashape. This is our 3D model, and this is a model of our river corridor. So we have sand piles near this river, and for example, if you want to calculate, these are the contour diagrams or the contour map. This is the contour map showing the contour lines. For example, if you want to calculate the volume of this sand pile, okay, for this particular sand pile, then what we can do, we can just go to the draw polygon, and I just want to draw the polygon. Okay, this is my polygon, this is my polygon, this is my polygon. Double click. Okay, this is my polygon. First of all, I will select my polygon, then I will just do the right click and go to the measure, and I will see the profile, the elevation versus the length profile, and I can see there is one undulation of, for example, this is 50.6 meters and it is 55.6 meter, which is our mistake during the modeling. And if we see here also, we can see we have just done the mistake of creating one point on this tree. Okay, so I will just click this point and I will just move this point. Now from my 3D view also I can see whether it is okay or not okay. Okay, now it is okay. Now I will again click the polyline and go to the measure. Now I can see my profile. It is 50 meter, 51 meter and 52 meter. Is okay. Now it is okay. If this is okay, then what we can do, we can just make some corrections also, like we can just, okay, we can also add point also. If we want, we can also add points to make our to make the correction. We can add points also if you want. For example, in this case, we can add points here also, here also. This way, we can make the correction also. Now I will again select the polyline and just do the right click, and I will just go to the measure. And this is my profile view. It is okay. And this is my volume calculation, and the volume calculation is from the base fit plane. The volume calculation above the line or above the polyline is 6087.51 cubic meter. Similarly, below is 6.6 times 587. This must be near to 0. In our case, if this value is 6087 and this value is 6.6 times, which is very less than this value, and this value must be nearly equal to 0 if we have a very flat or flat plane. But in our case, this is not the completely flat plane, so we will have some value here also. In this way, we have the total volume of 6080. That is the total volume. That is the volume above minus the volume below. That is the total volume. Okay, this is by using the base fit plan. Okay, similarly, if I want to calculate the volume using some reference level or the ground level, then what I can do, I can just go to my draw point and I just want to draw one point. Okay, I just want to draw one point here and just do the right click and do the measure, and I give the elevation of that point, that is 50.648. 50.648. Okay, now what I will do, I will go to select this polyline, right click, and the value 50.642. Okay, now I give the label, I give the custom label, and I just give the update, and I can see some change in the volume. This is with respect to this value, but because this is not a completely plain surface, we have the this is not the completely plain surface, so the best way in this case will be to use the base fit plane. That is, that gives us the result 6087 or 6080 cubic volume. If we use the custom value, it gives 6286. So we know the best will be to use the best fit plane, that is 6080 cubic meter volume. This is the volume for this for the volume that is surrounded by this polyline. Similarly, in this way we can do the calculation of volume of other sand piles also. But the important thing is we need to have the DEM file, digital elevation model file. Only after having that file we can do the calculation of the volume. We cannot do the calculation just from the model, 3D model or the tile model. Okay, we need to have the digital elevation model. In this way we can calculate the volume, area, length, perimeter. Thank you.